Hello, everyone. It's really nice to be here, and I guess it has been a long day, so I'll try not to torture you too much. So I'm Juste, or Justina as my full name, and I'm a developer advocate at Rasa. Rasa is a Berlin-based startup which is working on open source conversational AI software. Software that can be used to build chatbots. So if your company or you yourself want to build your own Siri, you can definitely use Rasa for that. And today I'm going to look into how to build a chatbot using machine learning. Okay, so some motivation of why would you use machine learning, and in general, why would you want to build chatbots? So chatbots are already around, and they are changing the way we interact with apps, the way we interact with the software. And it basically simplifies tasks which are occupying too much of our time so that we can focus on other tasks in our daily lives. So, for example, here I have an example where a user moves to another city, and there are so many things that you have to take care of when you do that, and one of them, of course, changing an address. And a chatbot like this can do this operation, and the user can change their address just by using their smartphone or their laptop. But of course, when you build chatbots, you have to keep in mind a few things, that chatbots have to be scalable. And in this example here that I have, you can see that sometimes a chatbot is not picking the right information that the user is providing. So it is important to build chatbots which can adjust and kind of fix themselves. And also, there are so many different ways how users can ask the same questions. And it is, of course, very important to build chatbots which can handle conversations like that they wouldn't follow one specific path, and that they would be able to adjust to so many different ways of interacting with them. So what is Rasa? As I mentioned, Rasa as a company is working on software for conversational AI, and the main software stack that Rasa is developing is called Rasa Stack, which consists of two open source libraries, Rasa NLU and Rasa Core, and they are open source, so anyone can use them and hack them. And Rasa NLU is a library for natural language understanding. So you would use this type of library to teach your chatbot to understand what a user is saying, so what they mean by asking questions or saying specific things. And Rasa Core is a library for dialogue management. So when a chatbot learns to understand what the users say, they have to learn to respond. So Rasa Core uses machine learning to predict what action a chatbot should make at specific state of the conversation. And it's all based on machine learning, and that's why it learns from the data. So there are no kind of predefined rules or like happy path that a users have to follow. But we will look into it in more detail quite soon. So this is the overview of how the stack works on high level. So let's say a user has a question, like what's the weather like tomorrow? And the first stage that this message would go through is a connector. So it is some kind of interface. So for example, it can be a messenger or Telegram or Slack or your own custom UI that you developed. So basically an interface that a message comes in through. And then this message goes through input module, so-called ears. And this is where Rasa NLU comes in play. It takes that message, it extracts structured data from input sentences, and helps chatbot to understand what the user asked. So, for example, in this specific example, what's the weather like tomorrow? A chatbot would understand that the user asked for weather forecast, and it will probably understand that a user wants to see the weather forecast for tomorrow specifically. So when it gets all these details out of unstructured user data, they all go to dialogue management, so-called brain. So this is Rasa Core stage, where chatbot takes all these extracted pieces of information and some other bits and predicts how a chatbot should respond. So responses can be different things. It can be just like simple text responses, or you can also connect your chatbot to some kind of backend. So for example, retrieve data from a database or make API calls and use that extracted information as responses to a user. And then, of course, you need an output module, a mouth for your chatbot. So chatbot has to respond. And there are also different ways how you can do that. So you can either use, as in Rasa Core, templates of how a chatbot would respond in specific situation, or use some kind of natural language generation. And then, of course, a message should go back to a user on the same interface as it was provided. So it goes back to a connector, so a messenger or anything else you are using. And so response can be, it will be sunny and 20 degrees Celsius. Okay, so of course there are alternatives, and you probably heard of some of them. So, for example, Dialogflow, which belongs to Google, or Wit.ai, or Louis.ai, but they are hosted solutions. And Rasa is, as I mentioned, is open source, and probably for now, like the main stack, which is leading open source conversational AI software out there. So why would you use Rasa and not some kind of hosted solution as Dialogflow? So first of all, Rasa runs locally, and you can build chatbots who runs on your local machine, and you don't have to host it on a specific platform. If you prefer, you can host your chatbots on the cloud, on your preferred server, or like basically wherever you want. There are no restrictions for that. Another point is that you own your data. So that means that the training data you are using belongs to you. You don't have to provide it to some kind of specific company that will maybe later use it themselves. And it's very important, especially for enterprise companies, because sometimes the data you're working on is very sensitive. You can't really disclose it. So with Rasa, you own data for yourself. And since it's open source, it's hackable. So you can build things on top of Rasa. You can use your own preferred models. You can tune them to adjust to your own domain and make changes and just basically have fun with it and make improvements the way you want. Okay, so what the session is going to be about. So as I mentioned, we are going to look into how we can use machine learning to build chatbots. And the roadmap for this session is going to be first, we are going to take a look at natural language understanding, so Rasa NLU, and a little bit under the hood, like what's happening and how information is extracted from user inputs. Then we're going to do a little bit of coding. Then we will look into dialogue handling and all the pieces that goes there. And as well, we will do coding as well. We will develop a dialogue management model. And I will mention a little bit about the research that Rasa is working on. And I think there will be some time for questions as well. But if you have some burning questions throughout the talk, definitely raise your hand and feel free to ask. Okay, so for this session, I'm going to use Jupyter Notebooks, and I have shared a link to those Jupyter Notebooks on Slack. So if you saw that and had a chance to got those data from the repository, which is written here, that's great, but you have time to get it right now because I will talk a little bit about NLU. So, and the link will be in subsequent slides as well, so don't feel rushed to memorize it super quickly. Okay. So I will start with Rasa NLU and how it works and what is under the hood. And again, there is a link to the GitHub repository, so if you want to still get it, it's there. So, as I mentioned, Rasa NLU is an open source framework for natural language understanding. And the main idea is that it takes unstructured user data, any type of text input, and extracts structured data. In the world of Rasa NLU, the structured data consists of two main things. So it is intent, which is an intention of what a user is speaking about or what it is asking, and entities. Entities are the pieces of information from this unstructured data that would help a chatbot to make more specific answers. So for example, right here, so the same change of address example, a user said, I have a new address, and it's the specific in San Francisco. So a chatbot should understand that the intention of this input is address change. So as you can see, the intent, and also what are the details that would help a chatbot make more specific action or more specific response. So this is, for example, an address that a user already has, so that when a chatbot knows where a user lives from now on, it will be a lot easier for a chatbot to just go and make specific action using that address. So the goal is basically to extract those two parts of information, entities and intents. So how does it work? So again, I have some high-level overview. And when a user, for example, asks what's the weather like tomorrow, it goes through natural language understanding stage. Basically, what happens is that it goes to vectorization stage. We would tokenize each word in this input sentence into tokens, and we would look up word vector for each of the words. Then we would use word vectors to create representations of the sentence, which are then going to be used to train the model. And it is a classification problem, when we have an input, what's the weather like tomorrow, a result of this classification problem would be request weather, for example. So how that works. So this is one of the examples of how it can be done. So when you have an input, like what's the weather like tomorrow, as I said, you have to tokenize each, well, not like you have to, but Rasa NLU tokenizes each word into tokens, and then a word vector is looked up for each of the words. And by taking an average of all those vectors for each word, we create a representation for the sentence, and that sentence representation alongside the label is going to use to train the model, which in this case is SVM. For a test input, so for example, something like this, what the weather like tomorrow, it will go through the same stage, and the result of the classification would be one of those 5 labels. So is it greet, is it goodbye, thank you, request weather, or confirm. And of course, since it is a multi-class classification problem, for each input you would provide to a chatbot, it would assign specific intent, one of those that you have in your training data. So for example, if you asked, in this example, if you asked something like, I would like to have a pizza, it would still try to assign one of those 5 intents here. So something to keep in mind. Okay. And another stage is entity extraction. So entities, as I mentioned, are pieces of information that help a chatbot to make more specific actions and to understand more specifically what a user is asking. So it is a little bit more complicated a process, but well, in a way still quite similar to intent classification. So we also use a tokenizer, so we have to tokenize input sentences into tokens, and usually it can be something very simple like a white space tokenizer. And then we use part of speech tagger, which assigns what is grammatical meaning of the word. So is it a verb? Is it a noun, adjective, etc.? And we use chunker as well, and chunker creates like bigger chunks of words. So for example, an address, it can consist of more than just one word. So that's why we use chunker as well. And then there is a named entity recognition and entity extraction stage. So for input like what's the weather like tomorrow, the goal would be to extract the word tomorrow as an entity so that it would be used later on in later stages for a chatbot to make an action. Okay, and how can you do it? So there are actually more than one way. So for example, if you have a sentence like this where you want to extract two entities, one entity is a cuisine for burrito and another for location for an address. One of the examples could be like a very simple approach, just use a binary classifier where at first you would predict if there is an entity in the sentence at all. And then on top of that, you would have another classifier which would predict what entity that is. But what really works a lot better and what is a lot better approach is direct structured prediction. So when we actually look at each intent in the sentence, and then surrounding intents, like surrounding words, have an influence and have a prediction power on that specific token that you're trying to predict what it is, what intent that is, entity that is. For Rasa NLU, we use conditional random fields, and that works pretty well. So basically, it looks at surrounding words and surrounding tokens and predicts what entity is the one that is a target entity. It works quite well, it's still not the most complicated approach you can take. But of course, you can probably use some deep learning for that as well. But I think it would require a lot more training data. Okay, so it's time to write some code. Okay, let's see. So as I said, I really encourage you to follow along, but if you don't want to follow along, you can find all the code on GitHub. So I have a repository, which I hope you had enough time to get. And it has three main Jupyter notebooks. I just want to point out quickly. I'm going to use Rasa Workshop Starter. So this is a code which is not completely filled, and I'm going to do it right now. And then if you want to just see how the result is going to look like, you can use Rasa Workshop Completed, which has all code there. And if you want to see the results as well, not only the code, you can try and use Rasa Workshop Completed Executed, because it has all cells executed already. And all the other files that you see here, I will explain them later on, but they are basically the outputs of some of the commands we are going to use. Okay, so we are going to build a little chatbot, as I mentioned, and it's going to be a fun chatbot, nothing too complicated. We're going to build a chatbot which can check in about how the user feels, and then based on the answers, make specific actions. So, for example, if you feel super tired, you can tell this information to a chatbot. That's a good question. Oh, yeah, I can. Oh, that's too much. Go back. I think that's too big. Is it better? Or... So the question was what is used for entity extraction specifically? As I mentioned, conditional random fields is the most popular approach. So as I mentioned, it works really similar to n-gram, so it looks for surrounding words to predict what is the target word or a token is, what kind of entity. Conditional random fields. Cool. As I mentioned, we are going to build a fun little chatbot, which will check in about how the users feel, and then we'll take specific action based on the answers. So this entire workshop, coding workshop, will go, I will talk a little bit about installation, then we will build an NLU model. After that, we will build a dialogue management model, and I will share some resources to read after, and maybe share some tips depending on how much time I have. Cool. So the first stage is installation. However, I heard that there are some issues with Wi-Fi connection, so I will not going to do this step. But basically, I can just walk you through. So this cell I can run. So it's just configuration for a Jupyter. It's not something related to Rasa specifically. I'm just initializing some logging so that if things go wrong, I could check later on where the errors were. And also just a little function which will help me to print out the results a little bit nicer. Okay. So now the installation. So as I said, I'm not going to do this just because I want to avoid some connection problems, but I will just quickly explain. So we are going to use three main libraries, Rasa NLU, Rasa Core, and Spacy. And the Spacy provides language models, so those pre-trained vectors which we can use and train Rasa models with. With this, I'm just simply installing Rasa Core and Rasa NLU, and since we are using Spacy, it will install Spacy as well as part of Rasa NLU. And with these two lines here, I'm simply downloading the Spacy English language model, so the vectors which I'm going to use, and just simply loading them in my environment. Okay, and we should be able to check if everything worked well. So I'm just checking which versions of Rasa NLU and Rasa Core I have. So I should have Rasa NLU 0.12.3 and Rasa Core 0.9.6, which is as it is. And also I should get some results from the language model. In this case, I'm just going to print hello world if everything worked well. And Spacy also has a few different sizes of models and those pre-trained vectors. So there is like small model, medium, and large. I would suggest using medium. Large might be too big, depending on the domain you're building your chatbots in, and small also might have not sufficient vocabulary for your domain. Okay, so yeah, I did got my hello world message, so I think everything is fine. Another tool which I'm going to use is GraphViz, and if you are doing things live and if you get any errors with this, don't worry, because GraphViz is quite stubborn library to install, but I will show you the results as I go, so yeah, you don't have to worry too much about that. Okay, let's start with our NLU model. So the first thing that we have to do for any machine learning model to get some training data. For chatbots, it is quite common question, how do you get training data in general? Because it's not like some type of data that just hangs around publicly on internet. And it's sometimes quite complicated to get any data if you are building chatbot for a very specific domain, and there are no conversational data out there. One of the ways which I think is a good start is to play a little game and pretend that you are a chatbot yourself, and then either ask your friends or colleagues to ask you questions for you to answer as if you were a chatbot, and just collect some conversations like this. And it serves not only one purpose, it's also a good way to validate the idea for your chatbot and also see the limitations like if some tasks are going to be super difficult for you, maybe it's a good food for thought, like how your chatbot would go around those problems and how to maybe simplify things and so on. So basically, this is what I did, and I have 3 conversations which I'm going to use as a basis to generate some training data specifically for Rasa NLU, because we will have to make some changes in the format and write it in a Rasa NLU format. As I mentioned, for Rasa NLU, training data consists of intents, entities as labels, and user inputs as examples. So what I will do now is I will just go through those conversations quickly, and I will create the intents, which I'm going to use for training of my chatbot. So I think I will just keep it like this so that you could see the conversations as well. So the conversation number 2, there is a one up as well, but so a user started a conversation with saying, hey. So that means that a user is greeting a chatbot, and for this reason, we have to specify an intent for this in our training data. So I will create an intent, which I will call greet. So this is the meaning of a user input. And now I will provide an example of this input. So it is going to be, hey. Okay, so a chatbot responded, hello, how are you doing? And a user said, I'm very sad. So it is not greeting. It is a user saying how they feel. And that's why I will create another intent. Just maybe do the tab. And I will call it maybe mood unhappy. So a user feels unhappy. And again, just simply providing an example, I am very sad. Then a chatbot says, to cheer you up, I can show you a cute picture of a cat, a dog, or a bird, and you can choose one. And a user says, I would like to see a picture of a kitten. And this is a new intent because it's not greeting, it's not saying that a user is unhappy, it's just providing a little bit more information, what a user would like to see to cheer up. So I will create another intent, which I will call just simply inform, since it is just providing a little bit more details. And just like with previous examples, I will provide this example. And a chatbot said, here is something to cheer you up, did that help? And a user said, yes. Now they feel happy. So again, it's not greeting, not saying that a user feels unhappy or providing some information, and that's why we create another intent, which I will call it affirm, because it's a user says yes. And example is yes. And a chatbot said goodbye. And now just to illustrate things a little bit more, I will go through conversation number 3. So a user started a conversation with, hey, it is greet. We already have an intent for this, so what we do, we just simply add this as another training example. Chatbot said, hello, how are you doing? And the user said, not so good. And the only thing that could help me feel better is a picture of a puppy. And we have an intent for this as well. So user says they don't feel really well. And it would go to, as another example, to intent mood unhappy. Maybe I can copy. Cool. And then a bot said, here's something to cheer you up, and did that help? And the user said, no. They still feel unhappy even seeing pictures of puppies. And this is another intent because we don't have intention for this yet. So I will simply create a new one. Intent. I will call this deny, since it's just simply saying no. And here will go the example. And then a bot said goodbye, a user said bye, and that is another intent because we don't have intent for users saying goodbye yet. So I will just do that. Goodbye, and a user said goodbye. So basically, this is how generating training data from scratch looks like for NLU. We have intents, which are the labels, and we have training examples as text inputs. One more thing that goes into Rasa NLU are entities. So entities are... The question? Mm-hmm. Yeah, that's a really good question. Actually, chatbots, for chatbots is quite complicated, like to extract more than one intention from one sentence. But of course, as humans, we use really complicated language, and that's a really good example. Rasa NLU recently released a new pipeline, which is based on TensorFlow, and it learns word vectors from scratch, and that enables identification of more than one intent per sentence. So it's like, and in this case, an intent would be like a combination of two tokens. So you could say that this example could also be mood unhappy plus show me a picture or something like that. So yeah, it was released quite recently. I will show you where you can read more about it later on. Mm-hmm. Yeah, so of course it's quite tedious to write data by hand. I would not recommend to do that for big chatbots. There are some tools that you can use to make it easier. So Rasa NLU also has a UI which just makes all the process a little bit easier, but also other tools like, I think it's called Chatito, basically, you can define what intents you want to have and what entities, and then you can just generate a bunch of examples for, and also you can define what kind of information you would like in those text examples, and then just generates a bunch. So I think that would be a best workaround. I will just write it here quickly. I think it's like that. But that might be just one T. But you can drop me a message after, and I will look up and tell you for sure. Okay, so another thing that I mentioned are entities, and the pieces of information that for a chatbot would be useful to know. Since it is a quite simple example that we're using here, I can only see one specific entity. So in some examples, we had that a user wants to see a specific picture that would make them feel better. This is information that would help a chatbot to show an exact picture, like of a puppy or of a cat or of a bird and so on. And we can train the model to extract entities by simply labeling them in our training data. So for example, I have one example here. So when a user says they are sad and they would like to see a picture of a puppy to feel better, so let's extract this puppy word as an entity, and I do that by just adding brackets, and then I just simply provide the name of this entity, like how I want to call it, and I think I will call it group, just what kind of group of pictures a chatbot should look for. The same for this example here. So I have a kitten, so it is another training example that a chatbot could use to train entity extraction. So I just do the same. I will label, and I will provide the name group. Now, another thing. People, as I mentioned, speak in a complicated way, and if we would train the chatbot to only look for cute pictures, if we always just say words specifically puppy or specifically a kitten, it would be super limiting, because some users could say, oh, I would like to see a picture of a dog, or I would like to see a picture of a cat. And to go around this problem, Rasa NLU models have a feature called the synonyms. So basically, you can define what kind of other synonyms of that specific word are out there, so that they would still be classified as one specific group. So how do we define synonyms? One of the ways is just to simply provide the name like what kind of overall value of this intent should be. So for example, here I have a kitten, and I can call this group cats. So if I would have another example where a user said, for example, a picture of a cat, that's a good example. So I would extract this as an entity. I will assign entity name, and then the value, so the one that will actually be extracted, and it will also be cat. So that, in this case, like kittens and cats and everything will be extracted, and the value of this entity will be cats. So that then you can use it to make API calls, you can use it to retrieve data from database, and it basically generalizes a lot better on things. Any questions about creating the training data? Mm-hmm. Yeah, but since it is classification problem, like there is a specific label which you have to extract, and the entity value is that label that is getting extracted. So if you would just have training data like this, it would still understand that, for example, these two entities are entity called group, but the value is going to be the exact value that it will find. So that's why you use synonyms. Cool. So I have just a very few examples here, and it's definitely not going to be enough. A question.
Will the system later be able to recognize synonyms that I have not written? Like you use the word doggo in your examples, and calling a cute doggo just emerged a few years ago as a meme on the internet.
Mm-hmm.
And will the system be able to handle such things, newly emerging words for the same things I already wrote down there?
Yeah, it should, because of course you don't have to, when you create training data for any machine learning model, in the end you are going to test on some unseen training examples, and of course with sufficient amount of training data it should be able to extract the entity and the value of that word. So as I mentioned, you need sufficient training data. So these few examples I have, they are not going to be enough. And what I have a little cheat that I'm going to use. And I just have a little bit more of training data examples. So the same intents that I defined, but just a little bit more possible ways of how people would say these things. And I'm just going to simply provide this data here. So as you can see, just a little bit more examples of like saying that a user wants to see a picture of a dog or a cat and so on, or saying that user is unhappy and so on. Okay, so now I'm going to train the model, and before I do that, one more thing is that is necessary is a training pipeline. A pipeline defines how those user inputs are processed and how this information is extracted, so how we tokenize sentences into words and so on. So I have the beginning of this pipeline written here. So as I said, I'm going to use a pre-trained spacing model so that I would have vectors which I could use to train the models for Rasa. And I'm using NLP spacing model. It's an English model. And then I'm defining what tokenizer I'm going to use. So it just simply splits sentence into tokens. And the featureizer, also based on Spacy, which combines all those word vector representations into sentence representation. And the classifier itself, which is going to be used. And in this case, I'm going to use Spacy sklearn-based SVM. And a few more things which I haven't included here. So if you are also doing entity extraction, you should specify this as well so that your model would know that it should look for entities as well. So I'm just going to quickly add those here. So for entity extraction, I will use conditional random fields, which is called CRF. And also, since we use synonyms, it is also necessary to tell your chatbot that there are synonyms and that a chatbot should extract words that are under the same synonym group as one specific value. So I will define this here. And it is called, I think it is called, NER synonyms. No. Yeah, so this is how the pipeline looks like, and the input sentences are going to go through all these steps one after another. Like it's not really like that you have to specify them in specific order, but like in how NLU architecture is. Cool, and then we can train the model, and I'm going to run it. It shouldn't take too long because we don't have too many training examples. I'm just going to quickly explain what's happening while it's training. So first of all, we are loading training data, so those examples that I have written previously. And then I'm just simply initializing the trainer, which will take care of training the model. And we have to provide configuration file so that a model would know how to parse incoming messages from a user. And then I'm simply calling train function, which trains the model. And I save the model in specific location where I want to. So this path can be any type of path where you want to keep your model. And I specify a fixed model name so that it would be easier later to find where the model is and to feature it easier. Cool. So the training finished. So it's really small model. So yeah, I think it did just 12 fits. And when we train the model, what we want to do, of course, we want to test it. So I can do that by using interpreter parse method from Rasa NLU, and I can provide an input, user input that I would like to test my chatbot on. So let's try. I will just say, I will try hi. Let's see if that works. Okay, so these are the results of the model and prediction. So the first thing we can see is intent and intent classification results. So a chatbot thinks, using an NLU model, that saying hi is greet, which is correct. And you can also get the confidence level, like how confident a chatbot was about the specific prediction. It would also have any entities if it found any. It didn't. And also we have confidence levels for all the other intents that we have in our training data. I will try another one, something with entities. I will try, show me a picture of a dog. Okay. So yeah, so it thinks that it is unhappy, but I think it predicted mood unhappy because of those examples when I had that a user said, I'm unhappy, but just show me a picture of a dog and I will feel better. And we can see an entity. I will explain why it is Shibas instead of some kind of dog group. It is for an API. But basically, yeah, so this is an entity which should be a dog, because you can also see that start and end symbols are from 23 to 26, so it's three characters. So it's definitely a dog extracted as an entity, and it just has a value which I assigned in my training examples for this synonym. Mm-hmm. So we use taste for dialogue management. For NLU, it's just like what kind of training data you have, and basically that's what it uses to make predictions. Okay, so this is our training model, and before I move on to the next stage, I am going to talk a little bit about dialogue management, unless you have any more questions about things I showed. Okay, so yeah, So we have our model, a chatbot understands what I say. That's great. Okay, let's see what's next. So, dialogue management and how it happens and what is under the hood. So first of all, why would you want to use dialogue management, using Rasa Core and machine learning in general for dialogue management? It allows you to ditch state machines. So by state machines, I mean when you use some kind of rule-based approach and create a happy path, or probably more than one, just one happy path, but still you kind of predefine the journey that a user would take when it talks to a chatbot. And since Rasa Core is using machine learning and is learning from data, you don't need to predefine any rules at all. It picks up patterns from training data that you provide. So I have built some chatbots using state machines, and it is a nightmare. It's easy when you have a really simple bot, but when you try to build something a little bit more complicated and more scalable, it's just really, really big hassle to go through all the rules and try to find the place where this new rule would fit in. Also, some approaches are using reinforcement learning, learning from user feedback, but the problem with reinforcement learning is that it requires a lot of data to train at first, and with chatbots it's quite a challenge to get a lot of training data, and also it's quite difficult to define a good reward function so that it would learn correct things. And it's not really too complicated to use Rasa Core. Even if you don't know Python, there is a way to use Rasa Core. You can use HTTP requests, and you can use Rasa Core with any other language you want. So those actions that are predicted, they might be executed in any other programming language. So it just makes things a lot easier. So I mentioned why machine learning is that it picks up things from the data and not from predefined rule sets of how a chatbot should respond at specific stage of the conversation. So as you can see, there are so many different ways how a conversation could start and go. So a user could say goodbye, a user can say thank you or greet, and using state machine or rule-based approach, you would have to implement a rule for each of them. And using machine learning, you provide training data, and it picks up those patterns from training data itself. So if you're trying to build a more complicated chatbot using state machines, it basically turns into something like this. I'm pretty sure this is a representation of quite simple chatbot using state machines. I think it can do just a few things, but it's, I think the chatbot that I was building myself looked quite similar with state machines. Okay, so how Rasa Core works and how it does all this machine learning magic. From NLU model, NLU model extracts structured data from user input, so intents and entities, and they are combined with the specific state, so like where the conversation is. They are used to also Rasa Core looks at previous actions, so like what a chatbot did before and what was previous state, and it uses this information to predict the next action. How it does the prediction, so it can be also an SVM or it can be a recurrent neural network, And then when it makes a prediction, this new state that got predicted, it becomes an updated state, which is then probably combined with some kind of API call or like retrieving data from the database, and a chatbot simply makes a response. Okay, and a little bit deeper look into Rasa Core architecture and how things work. So in Rasa NLU stage, we perform intent classification and entity extraction details, and they are fed into recurrent neural network. alongside intents and entities that were extracted from this input. For example, what's the weather like tomorrow? Using Rasa NLU model, we have additional details, so they can be API calls or entity outputs. Like what kind of additional details were provided by a chatbot. And also it is using previous conversations to make predictions for the next ones. So just one other thing. As I said, Rasa Core model is using previous conversations as well, and that's why it's a recurrent neural network. So at first it gets previous conversations, and then it gets current state, and that's why it works as a recurrent neural network. Another thing that you might want to have is an action mask. So, for example, you would like to limit your chatbot at some specific stage to not perform some specific actions, for example, to limit the performance for specific clients or something like that. And you can use action mask. It is not yet implemented specifically for Rasa Core, but there is a lot of research done. I'm pretty sure it is mentioned and looked into in the paper that Rasa was working on recently. So hopefully quite soon it's going to be implemented in Rasa Core as well for you to use. And once it's done, all the probabilities are renormalized so that a chatbot could go back to an actual regular performance of being able to predict all the actions that were in training data. So when the predictions are finished, there is a sample action which is produced, so what a chatbot thinks it should do next, and it is combined with some specific actual action, so making an API call or just providing a text response, etc. One very important thing is that all the cycle here, it doesn't have to be just like one thing, and like it doesn't have to run only once per user input. So there can be one user input and can be like 5 different actions that a chatbot performs subsequently. So it really just depends on the state of the conversation and the domain and so on. Yeah, and then it provides an answer. It will be sunny and 20 degrees Celsius. Mm-hmm. Yeah, so with Action Mask, you can limit limit the amount of actions that your chatbot can perform. So in your training data, you would probably define, for example, 5 actions, but at specific state of conversation or for a specific domain, you would like to limit your chatbot so that it would be able to predict only 3. So you can use Action Mask for that. And since you are excluding some of the actions, you have to renormalize predictions so that they would sum up to 1 again, and that it would just work as it should be. Okay, time to code again. Ooh, not there. So I'm going to get back to the Jupyter notebook where I left it, and we are going to build a dialogue management model. Oh, one thing that I forgot to mention about Rasa NLU, and it will apply to Rasa Core as well, is that you can use also, you can evaluate your models. So this code right here, it will load the model and it will perform like kind of like a cross-validation, like how good the predictions are depending on your training data. Of course, you should define some testing and training data for this. You shouldn't really test on your training data. So I think I should get results here in a second. Okay. Yeah, so basically it provides precision, recall, F-score for each of the intents we had in our training data, and confusion matrix, which basically shows how many times goodbye intent was predicted when it had to. But again, I'm doing this on my training data, something that you should never do. Okay, dialogue management. So I will start with training examples again, but I'm just going to quickly show you how to do that. I'm not going to spend too much time because I have some more exciting things to show you as well. So in Rasa Core, training data consists of stories, and a story is a representation of an actual conversation that a user would have with a chatbot. User inputs are extracted in a way of intents and entities, like combination of intents and entities, and responses of a chatbot are expressed as actions that a chatbot would make at this specific state of the conversation. So one of the examples could be, I will just write one, so for example, story number 1. So this is just basically providing the name to this story. It's just for debugging, but it just makes it easier to look at things later on. So, for example, I can write one story where a user said, for example, hello. That would correspond to intent greet, and I'm going to just simply provide this intent that a user greeted a chatbot, and then a chatbot would respond with probably something like, hey, how are you feeling today? And it would, this response should be written as an action that a chatbot would make. So I could write it as, for example, utterance, for example, greet as well. So a user said hello, a chatbot said hello, how are you feeling today? And then let's say a user said, I am feeling sad. And again, we have to provide the intent that would be assigned to this input. And in my examples, I think it was mood unhappy. And just to show you one more thing, so if you have, so let's say that a user said, I'm feeling very sad, and please show me a picture of a puppy. So if you have entities that you want to be extracted from your training data, you should also specify them in your stories. So I will just simply going to do that by providing, I think I called it group. So it is the name of the entity and then the value that was extracted. So let's say it was a cat or a dog. And then let's say a chatbot looked up the picture for a cat, and it should also be expressed as an action. So it could be, let's say, action, find picture. And as I said, there can be more than one action for user input. So a chatbot could find a picture, and it could also ask something else like, did it help, for example. So it could be also like utterance, let's say better, like, do you feel better? And then a user would respond with something. So maybe they said, yes, I feel better now. So then I would, again, provide an intent that corresponds to this input. So it would probably be affirm, if I remember correctly from my examples that I gave previously. And probably a chatbot would respond with something, I don't know, like maybe goodbye, like you are happy now. So let's say utterance, goodbye. So basically, this is how the training data generation looks like, and we have some questions. Mm-hmm. Sorry, can you? Yeah, it should be cats. So as I said. Dialogue management model looks at quite a few pieces of information to make predictions. So it looks at intents that are extracted from user input entities, so that's why we specify this entity right here. Also looks at previous actions and so on. So for training data and for the purposes of training the model so that it would know what specifics it should look at, it should know that here this entity will be extracted as well. Okay, so again, this is the same situation as with NLU model. One story is definitely not going to build good chatbot, so we need more. To build simple chatbots, you don't need huge amounts of training data. So for example, here I have a little bit more of training examples, so it's like 7 training stories, like 7 possible ways of how a chatbot could speak to, a user could speak to a chatbot. So I'm just going to add them here so that I would train a little bit better model. But basically, as you can see, the same thing repeats conversation throughout after conversation. So you have one story which represents an actual conversation a user would have the chatbot, another one, and so on. And of course, to build a chatbot which scales, you should include quite wide range of training examples. So if all of the stories will be like intent greet and then action utterance greet and then and they will repeat all the things again and again, your chatbot will learn just to make predictions like for the same things. But if you want to build a scalable chatbot, you should think of what other situations a user could end up with. So for example, saying no instead of yes at specific situations and so on. What do you mean by nesting? Yeah, absolutely. So yeah, I think I could just take some of those and just create more complicated ones with more turns and so on. But, yeah. Okay, I'm going to save this. And the next stage for dialogue management model, when you have training data, is defining a domain. A domain defines the universe where a chatbot lives. And in the world of a chatbot, this universe consists of details that it would be ready to see and act on. So, for example, it should be aware of intents. It should be seeing also what entities, so the ones we defined in the training data, also what actions it should make. Again, the same ones we had in our stories. And another thing that we can provide are the templates, and those templates correspond to possible actions that a chatbot could make once specific action is predicted. So, for example, when action utterance greet is going to be predicted, here we can define what kind of message it will be sent back to the user. So, for example, here a chatbot will say, "Hey, how are you?" Or when a user says that they are happy and an action, if it is predicted that a chatbot should respond with utterance happy, it will say, "Great, carry on." Important thing, you can define more than one possible action, so like it doesn't have to be one response over and over again. And you can do this simply by just writing more examples here. So for example, there are other possible ways how a user could say, a chatbot could say, "Hey." So for example, I would just write another one. I'll say, "Hello. Oh, wow. How are you doing today?" Or something like that. And it can be 5, it can be 10, it can be 20 if you want. And then when the prediction is made, they will be randomized. And it just really helps to make chatbots which are capable of being more interesting and not repeating themselves over and over again. Okay. So I'm going to save this right now. One thing as well related to domain and responses that a chatbot uses. So it doesn't have to be only text responses all the time. As I have mentioned, it can be an API call or it can be like retrieving data from the database. And since they are a little bit more complicated actions, so we can define them by creating custom actions. So I'm going to quickly show you how to do one. So this custom action is going to make an API call to retrieve an actual picture of a cat or a dog or a bird. And I'm going to use a live API for this. So I'm just quickly going to explain what's happening. custom action consists of two main functions. One which defines the name of the action that a chatbot will see, and the one will be predicted. So, for example, this action retrieve image is should be included in training examples if it should be predicted at some point. And another function, which is the body of things that are going to happen when this action is predicted. One thing. So this API call should be made for a specific type of animal, a dog or a cat or a bird, and how my chatbot will know that. So if you remember, we defined entities for that. So probably cats or dogs, well, actually shibas, are going to be extracted as an entity. And I can save this value and make my chatbot to remember what I asked and just keep it like in a context, so that whenever in specific state of the conversation when a user asks for this, a chatbot just remembers and knows which specific group it should make this API call. And we can save them, like those values of the entities, by filling in the slots. So one thing that I actually didn't do quite yet. So slots, as I mentioned, they simply save pieces of information that a chatbot should remember as the conversation goes, and so that it would be able to go back and retrieve those details. So I'm going to define them right here, so slots. And what I have to do, I have to provide the name of that piece of information that I want to keep track of. So since I want to my chatbot to remember what is the group, the entity that was extracted, I will simply provide it here. I think it's like that. And another thing that is important is to define the type of the slot, and different types of slots have different influence on how the prediction is made. So I'm going to specify a slot type text, and when type is text, whether or not this slot is populated, so if this entity is extracted and saved, is going to influence the prediction of the next action. There are other possible slot types. If you want your chatbot to completely ignore like the fact if the slot is populated or not, you can specify it as unfeatured, unfeaturized, and so on. But you also have to keep in mind like what kind of slots you are specifying. Okay, and then when you save your slots, what you have to do, what you can do, is to retrieve them in a specific action. So here I'm going to do that because I will need the value of this slot to make a correct API call. Tracker in Rasa Core is responsible for keeping the track of populated slots. So I'm going to call the tracker, and I think it's called getSlot function, which will retrieve the value of the slot that I'm interested in, and the slot name was group. And then once this getSlot method is executed, the extracted value of a slot is going to be populated in this variable. So what I'm going to do now, I'm going to just simply define an API call, which I don't remember by heart. So I will use requests get, and here I'm simply defining what API call it should be used here. So it's a publicly available API. You don't need any keys or any authentication for this API. And here, where I will have a value of what kind of, like, is it a cat, is it a dog, or is it a bird that this API should retrieve the picture of. And then some additional features of this API call. So how many pictures you want, I will ask for only one. And also URLs true. I will just simply retrieve a URL of this, and I will also ask for HTTP URLs. So you can use any API here, like it doesn't have to be the specific one. And since I have this slot kind of placeholder for a variable that I could use, so I will provide the value of my slot, which is group. Okay. And then, so this will return the JSON, which I have to extract and get the details that I'm only interested in. So I had to do a little bit of cleansing for this URL to look nicely. And dispatcher for Rasa Core custom actions is not only custom action, but for any action is responsible for sending out the messages. And here I can specify how a chatbot will respond. So I will say here is something to cheer you up. So this is how the custom action would look like. Again, it can be something else, retrieving data from the database, and you just define like connecting to the database and retrieving data using slots or not using slots, depends on how you want your chatbot to behave. And I'm going to save this. And since it is a custom action, my chatbot should know that this action exists. So I'm going to go back to the domain. And in the actions list, I will add this. And this is in main, since I'm using the Jupyter notebook. And this class for this custom action was called API action. I think that's all. Okay, so I'm going to save this now, and I will try to. If you want, you can, of course. I'm just going to retrieve a URL, which I'm going to click on. And another thing before I train is you can visualize your training data and see how the stories look like. So if the graph viz is going to work for me, hopefully, I will have a nice picture of my training examples. So basically, there's like the structure and how the conversations could go based on the training data that we have. So for example, a user could say hi at first, and then a chatbot would respond with utterance greet, or a user could say something about how they are feeling immediately without saying hey or something like that. And then a chatbot would respond. So it's a really good way to inspect your data and see if something doesn't really make sense, because of course to build a good training model you have to use good training data, so you can eliminate something that doesn't really help your chatbot to perform better.
How can you make sure the entity is not extracted and saved to the slots? How can you cover this possibility in action so that once I recall the slot is empty, that there is some way to still communicate to the user that he has to give some information about that?
I mean, if so, the question was if some data is not extracted, how to make sure that a chatbot can continue?
So we have this slot we need to fill to the API.
Mm-hmm.
And if it's empty, so the bot didn't extract the entity, but the things returned the right intent.
Mm-hmm.
It's performing this action, but the slot's empty.
Mm-hmm. So one of the ways you can do that is to use interactive learning. So it's another feature of Rasa Core, and this is how you can actually see what exactly a chatbot extracted or not, and then to fix some of the mistakes yourself, and then those corrections that you make are picked up by a chatbot, and it is using later on. But yeah, I think you can also implement some kind of check in your one of the custom actions probably as well, to check if this value is populated or not, and then if not, a chatbot makes specific response like, hey, I need some more information. Cool, so now I'm going to train the model. It will probably take a few seconds as well. And what I'm going to do, I'm just going to walk you through what's happening. I'm going to use, of course, the training data. No, not the training data, but I'm going to use the domain that I defined, so all the intents and entities and actions that my chatbot should know about, and the policies that should be used to train the model. And Rasa has quite a few policies which you can use. Yeah, it depends on the situation. Then I just load my training data and train the model. And you can see that you can specify the parameters for training as well. So to just test the performance, if something doesn't work well, you can tune those parameters as well. So here I'm just simply providing the training data that I used and validation split. So what percentage of your training example should be used for testing, and also the number of epochs, so how many passes of your data should be done during the training. So since I have a really small data sample, I'm going to use 200, which is still, I think, relatively high. So what it is doing, it's simply training the model and running epoch after epoch. And it finished. Yeah, and the model was saved. And now the exciting part. I'm going to give it a go and see how the chatbot behaves. So to do that, I have to load my model. And I'm using agent.load method here. And I'm loading the model, a dialog management model, which I just trained. And as well, I will need an interpreter, which I have to specify so that my bot would know what is going to be used to understand what the user said. So I'm using my NLU model, which I trained previously. You can also use other interpreters if you want. So in some cases, for example, regex might work pretty well. Depends. Okay, and now let's give it a try. Mm-hmm.
What's the interpreter doing?
Yeah, so interpreter is a model or a framework that you're using to parse incoming messages from a user. So I built an NLU model previously, and this is going to be my interpreter, but you can also use other interpreters if you like. Yeah, so for example, now I will start speaking with my bot, and I will say something, and it will be passed to the interpreter, the NLU model, and it will extract intents and entities, and we'll use them. Okay, let's see. So I will just say hello, and the chatbot responded with, "Hey, how can I help you?" Which means that an action greeting was predicted. Okay, I will say I'm very sad. And chatbot said to cheer you up, I can show you a cute picture of a dog, a cat, a bird, and which one do you choose? So an action, check in on the mood, was predicted. And okay, let's try. I will say, I will want to see a picture of a puppy. So it is thinking. Oh, okay. Okay. No, that didn't help me. Okay, but I see that it is, I either made a typo in my HTTP request, or is it just simply not having connection? Yeah. Yeah, so unfortunately, yeah, no, that didn't help me at all. Okay, so Java said bye. I can give it another try, but I don't have much hope. Say, hey, how are you? I am really bad. Okay, a cat. Okay, yeah, it didn't look too promising. So, okay. So unfortunately I can't show because of the network problems, but in the code that I provided, you can definitely test it out. Okay, so, and then if I want to stop the conversation, I will just do stop. And And also you can evaluate your model just like your NLU model, so get the same evaluation matrix for actions that it had and how it predicted. Cool. I have not so much time left. So I have some actions there which are not getting responses because of the network problems as well, so great. So basically you would have a matrix just like I showed you for NLU, but it would be for actions. It was, so something like this. But instead of intents, there would be actual actions that a dialog management model was predicting. Okay, so I have only 7 minutes left. So I'm just going to go back and just talk about a few other things that I would like to mention. I didn't have a chance to, I don't think I will have enough time to show you online training, so the one that I mentioned that you can actually correct your chatbot as you talk to it. So it's called online learning or interactive learning. So you simply train your model as well, but you see what predictions a chatbot made as it goes, what intents it extracted, what entities, and what action it is about to execute, like what action it predicted, and then you can just tell, no, you're wrong, and you should actually make this action instead, or that this different intent should have been classified, and then a chatbot would pick up those corrections. So yeah, if the behavior is wrong, you can just simply correct them and it would retrain the model. And it is also a good way to generate some training data, because you can then extract those correct conversations and append them to your training examples. So no, we are not going to code because I'm running out of time. And so the research that Rasa is working on, so one of the things that I mentioned previously for one of the questions, there is a new Rasa NLU TensorFlow pipeline which learns word embeddings from scratch rather than using pre-trained word vectors, and it is a more flexible approach because you can build chatbots for more specific domain. Since you're not using pre-trained vectors, you are less likely to bump into the problems of insufficient vocabulary and things like that, and you can also build chatbots in most of the languages. I'm not saying any language just because we didn't test them all, but most of the languages you would like your chatbot to speak. And also it can identify multi-intents, so that one user input can actually mean more than one thing. And we wrote quite a few blog posts and actual tutorials on that, so if you're interested, go check them out using those links. I think it would be like another session on this specific thing only. So here is an example of those multi-intents, so that you would have example like, hey, how are you? And something like, I don't really care. And then you would assign a multi-intent greet and don't care to this. And it can complicate things a little bit more, so you have to be careful with using them. Like, you have to use them only when it really makes sense, because I think it's quite an easy way to overcomplicate your chatbot. But on the flip side, it can, when used well, it can make chatbots a lot more flexible and generalizable. Another thing that Rasa is working on is generalizing dialogues across tasks across different domains, so that it can learn actions and states that it should go into when you have training data from, for example, things related to hotels and then things related to restaurant requests, and then you can combine them and build chatbots which can operate in more than one domain and share this training data. And before I finish, just some final thoughts. So, of course, as with any probably a machine learning problem, the goal is to actually get some training data, make that data in the correct format, and then get some feedback and see how it performs, and then make improvements and retrain your model and use improved model in the end. And if you are interested in contributing to open source, you are definitely more than welcome to do so. Some of the possible challenges you can work on, so for example, how to handle out-of-vocabulary words, because with pre-trained word vectors, some of the words may not be detected, and also if you have some really rare words or some very specific distinct domain, that's also quite a common problem. Multi-language entity recognition, so Rasa is working on that side as well, not only for intents but for entities as well. But your input would also be valuable here, and combination of dialogue models, so how we can combine more than one to create great models. And some readings for your research, for your raining day, and things that maybe you would find interesting. So, for example, this star space embeddings is the paper that new Rasa TensorFlow pipeline was based on, and got some inspiration, so definitely check them out. So all these links are also in the slides, which I will definitely share after. And quick summary. It's always best to start small and have some training data to get started. And the one tip that I'm going to definitely share with you, that I think is best to start with some small data set for training, build your bot, and then let people use it and collect more training examples, and then use them as like boost for your training data, because they are going to reflect real conversations a lot more than just you yourself like sitting and thinking of possible ways of how people could interact with your chatbot. As I said, you can definitely combine Rasa NLU and Rasa Core with other different languages. So I showed API call in Python, but you can do this in different languages as well, just simply using an HTTP request. And with using Rasa NLU and machine learning and Rasa Core, you are abandoning flowcharts. So you are learning patterns of conversations from an actual data rather than defining specific rules. Give it a try and build some great chatbots. And just a very quick heads up. Get in touch if you have any questions. I'm more than happy to help you out. And we are hiring. We are looking for machine learning product success engineers and machine learning engineers. So if you want to work on open source and conversational AI, get in touch.